And in today's episode, among other things, you'll see someone break a world record by creating a magnetic field 700,000 times stronger than Earth's. Unitree's humanoid robot enters anti-gravity mode and resists hard kicks and neck pulls without losing balance. Helium-3 mining on the moon. This is the new race for the fuel of the future in nuclear fusion. The Shuriken Enigma has just gained a concrete application. Alice and Bob's quantum cats take us to the first big leap toward the era of quantum computing. China's robot force increased by 300,000 in 1 year, surpassing the combined total of other countries. Let's understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Incredible Reality. Incredible, more stalling. Let's get to the video. Imagine parking your car in a garage and, without plugging in any cable, seeing the battery start to charge. Porsche delivers on its promise with the KIN electric vehicle 2026, its first model to officially feature wireless electric vehicle charging. While the idea sounds simple, making recharging as easy as parking is revolutionary. The technology will debut at the International Motor Show Germany Mobile Show in Munich, and Porsche makes a point of emphasizing that the main goal isn't just speed, but convenience. As Michael Steiner, an executive board member, noted, electric car acceptance still relies heavily on everyday convenience and charging infrastructure. The system works with two main components. On the garage floor, a 50-kilowatt plate connected to the power grid creates the energy point. Beneath the car, another plate with the KIN aligns itself automatically. When the two are in position, the energy transfer happens through a magnetic field. Same principle as wireless smartphone charging. Everything works autonomously, without cables or buttons. The difference is performance. Historically, inductive charging was seen as slow and inefficient, but Porsche says it has broken that barrier. The charging base delivers up to 11 kW at 90% efficiency, nearly matching wired home charging. In other words, the recharge times aren't quite the same, but the experience becomes incredibly simpler. And there's still an important technical detail. The board is air-cooled and designed to withstand temperatures ranging from -40 to 50 degrees. This enables year-round use. Remember, this isn't the first time a car maker has tried this idea. BMW tested something similar in 2019, but never released it commercially. Porsche, on the other hand, is already starting with a proposal of mass production. Although the feature doesn't come from the factory, it will be an optional feature installed only on the 2026 Cayenne electric vehicle. A recent Unitree Robotics video is gaining global attention. In a previous episode of Incredible Reality, we showed a few scenes, but now they've gone beyond those tests and showed their humanoid robot, one facing not only kicks, but also violent pulls and pushes. And the robot survived all the impacts thanks to a new system called anti-gravity mode. The scene resembles unofficial military training. Engineers push, kick, and pull the robot by the neck with a rope. Unlike older models that fell and stayed down, the G1 anticipates impacts and adjusts its center of gravity, and it gets up almost instantly, displaying movements that closely resemble the reaction of a human athlete. This resilience is possible because the G1 uses LiDAR depth cameras, 3D cameras, and several articulation motors operating in real time. When a blow hits it, the robot calculates how to reposition its body before falling, thus absorbing the impact with its knees and projecting itself back to an upright position. In extreme tests, it was thrown several meters, but always recovered on its own. The goal of this controlled brutality is to prove that G1 is not just a technical demonstration. It was built for real environments, factories, labs, and hospitals, where falls and collisions reduce efficiency. A robot that can handle this stress reduces downtime, saves time, and shows it's ready for robust, autonomous tasks. In addition, University of São Paulo researchers, they installed the N2 track system in the G1, allowing the robot to mimic human movements, even during strong disturbances. And this increases its versatility, making it a platform that is not only resilient, but also adaptable to different real-world scenarios. With 23 degrees of freedom, stable walking, and a price near $16,000, the Nitro G1 is among the most accessible and advanced humanoids available. These tests demonstrate not just strength, but the emergence of a new generation of machines, working alongside humans without constant manual adjustments. If before we saw robots falling over with a simple push, now we are facing a humanoid that anticipates, reacts, and resists. Essential characteristics for a future where machines and people will share the same workspaces and daily environments. Whether you like it or not, China is the clear leader of the 21st century's industrial revolution. I'm not here to defend A or B, I just bring you the facts. Last year, the country installed about 300,000 new robots in factories, exceeding the total installations worldwide. This achievement made the nation the top global automation hub, with over 2 million machines, 5 times more than the United States. The sources will always be in the description, all right? This movement is not accidental. Since 2015, Beijing's Made in China 2025 plan has aimed to lessen reliance on foreign technologies and to take the lead in areas such as semiconductors, artificial intelligence, and robotics. Government support has been crucial. Nearly unlimited state bank loans, low interest rates, subsidies, merger incentives, and help with acquiring foreign companies. The result is visible. Since 2017, China has installed over 150,000 robots annually and now produces a third of the world's manufacturing output, surpassing Germany, Japan, South Korea, the United Kingdom, and the United States. While United States factories installed only 34,000 robots last year, Chinese factories installed nearly 10 times more. One detail stands out, okay? In 2024, for the first time in history, the majority of robots installed in Chinese factories were domestically manufactured, revealing an industrial ecosystem that is maturing rapidly. And this wave isn't limited to just industrial robots. The country is already investing heavily in humanoids. Unitree Robotics in Hangzhou leads with basic models priced between $6,000 and $18,000 based on the machine. That's just a fraction of the price charged by Western companies. Unitree is set to go public by late 2025, further boosting the sector. The expansion is also supported by 2 strategic factors. On one hand, the workforce. Thousands of technicians, electricians, and programmers capable of installing and operating robots. This occurs despite the specialist shortage, which greatly increases salaries to over $60,000 a year. Artificial intelligence is also used to monitor, optimize, analyze, and predict equipment failures in the factory. The picture is very clear. With planning, investment, and scale, China is transforming its factories into automated fortresses, shaping a future where the production line will depend less and less on human labor. Picture installing thousands of solar panels in one of the world's harshest places, with extreme cold and constant snow cover, and sunlight is scarce for much of the year. That's exactly what happened in Tromsø, a city in Norway. Inside the circuit where the world's largest vertical solar roof is now installed, 6,400 solar panels were placed atop the region's largest cold storage facility. The project was carried out by Overace Solar, which reached 320 kWp of capacity, thus surpassing the company's own previous record. At Norway's National Football Stadium, the chief executive officer says this is the city's largest solar system and a model for future energy in cold and low light regions. The secret is in the vertical installation, unlike the usual slanted rooftop panels. Here they stand upright, just like rows on technological walls, offering 2 key advantages. Snow doesn't accumulate on them. Energy production is most efficient in the morning and late afternoon, when demand is usually highest. Also, the space between rows simplifies maintenance and allows use of rooftops once thought unsuitable for solar energy. The system has 1,600 size 1 vertical photovoltaic units connected to the facility's power grid. This lowers costs and reduces reliance on pricier conventional energy. Created with Enoch Total and backed by regional partners, the project proves that even in extreme environments, it is indeed possible to turn challenges into sustainable energy solutions. And humanity's ideas seem limitless. And now we think about how to concentrate an invisible force that is so intense it surpasses our planet's own magnetic field by 700,000 times. Chinese researchers reached a 351,000 Gauss field, surpassing the previous 323,500 record, and setting a major milestone in superconductor science. The Institute of Plasma Physics of the Chinese Academy of Sciences in Hefei led the breakthrough. They also had support from specialized centers in Tsinghua University. For comparison, Earth naturally produces just 0.5 Gauss. This major difference highlights the scale of the achievement. But why does it matter? Superconducting magnets are essential in advanced technologies. Magnetic resonance spectrometers for medical diagnostics, magnetic levitation for advanced transport and ultra-efficient electric power transmission, and, above all, research in nuclear fusion, which is the same reaction that powers our sun. In these experiments, strong fields form a magnetic cage that confines plasma at temperatures of millions of degrees Celsius, far hotter than the sun. That's why this ultra-hot plasma doesn't melt anything nearby. It stays suspended. To achieve this milestone, the scientists overcame complex challenges, managing structural stresses, unwanted currents, and stability at cryogenic temperatures. The secret was using both high and low temperature superconducting coils in a coaxial design, ensuring robustness in extreme conditions. The system operated at 35.1 Tesla for 30 minutes without failure. This achievement stands out for what it represents: a major leap that could speed up the race for nuclear fusion. Besides enhancing electromagnetic space propulsion, this also enables new clean energy and futuristic transportation. For a forward-looking perspective, here's something to think about. If today we are already able to manipulate such colossal magnetic forces, what will stop us from bending the very energy of the universe, the energy of the human species? It may take time, but it could happen, okay? With each advancement, the line between science fiction and reality becomes thinner and thinner. And maybe, just maybe, all right, we're one step closer to controlling even the power that shines in the stars. And that brings us to this next story here. Focus on it. The moon, long a source of poetic inspiration and exploration, is now becoming a site of more concrete conflict. The search for helium-3, a rare element on Earth but plentiful in lunar soil. After billions of years of solar wind exposure, this substance has fueled scientific, technological, and geopolitical ambitions. That's because it can play a decisive role in cutting-edge fields, from cooling quantum computers to clean fuel for fusion reactors. On Earth, helium-3 is acquired only in small amounts from tritium decay in nuclear stockpiles. That's one of the ways. And it's not enough to meet the growing demand. The moon may have up to 1 million metric tons scattered in its regolith. Though present in low concentrations, this disparity makes our natural satellite a strategic target for those seeking to master extraction technology. Helium-3's immediate value is in the quantum world when mixed with helium-4. It powers dilution refrigerators, cooling qubits to 1000 Kelvin, 200 times colder than outer space. This near-absolute cold is what allows the fragile quantum states to survive long enough to perform calculations. As quantum data centers expand, the demand for helium-3 could explode here on Earth, far surpassing terrestrial production. But the most enticing promise lies in clean nuclear fusion. Fusion with helium-3 produces charged particles, unlike deuterium-tritium fusion, which emits highly radioactive neutrons, with much less long-term nuclear waste. In theory, just a few dozen tons could power entire nations. It's still a distant vision, but powerful enough to motivate global strategic plans. The challenge, however, is colossal. Processing each liter of helium-3 will require handling tons of sticky, abrasive lunar regolith, which is hard to manage. To extract the gas, it would be necessary to heat the soil to high temperatures. Then, separate the helium-3 from the helium-4 and store it under safe conditions. Startups like Interloon are already designing machines capable of traversing the lunar surface, collecting, heating, and releasing the regolith, while isolating the precious isotope. All of this will require robust energy sources, such as solar concentrators or small nuclear reactors, and highly autonomous remote operations. And this is where science meets geopolitics. The United States and China are leading this race, each with distinct strategies. Washington is betting on the Artemis Accords and encouraging private companies, even making the first symbolic government purchase of 3 liters of helium-3. Beijing, on the other hand, sees the resource as key to meeting its energy needs, and that for thousands of years. That's why they've linked all of this to the Chang'e lunar program and also to national goals and deadlines. Russia, the European Union, and India are also trying to secure a place in this race, which could redefine the global balance. The story of helium-3 is about more than just mining. It's about who will have the courage and the technical capability to turn lunar dust into energy and power. The next decade may reveal if this dream, then it will become a new energy achievement, or it will remain as one of the greatest promises that humanity has yet to fulfill. Time. Time. One of the most relentless enemies of quantum computing, and it has just been defeated for the first time in history. Cat qubits, which are peculiar and ingenious versions of superconducting qubits. They stayed stable for over an hour, which seemed unlikely until recently. The achievement comes from the French startup Alice Bob, which had already surprised the world in 2024. With 7 minutes of stability, but now it has reached a new level. A level that was unattainable until now. The experiment used the galvanic cat project to power the company's L12 chip, which has 12 qubits. Cat qubits, unlike conventional qubits, are built to resist quantum computing's most destructive error, the bit flip, when 0 turns into 1 or vice versa, compromising all the calculations being performed. and the feat is not trivial. While regular superconducting qubits resist this error for only about 25 milliseconds, Alice Bob's cat qubits will reach over 60 minutes. To grasp this breakthrough's magnitude, picture holding a soap bubble in the air. It usually lasts only seconds, right? Here, scientists developed a technique allowing this soap bubble to last and remain intact for up to an hour. That's it. That's what the cat qubits did against quantum degradation. The discovery does more than break a record. By nearly eliminating one type of quantum error, researchers cut the need for physical qubits for error correction by up to 200 times. In practical terms, this means that the dream of scalable quantum computers with 100 logical qubits by 2030 is really getting closer and closer. The team also performed the Z-gate operation with 94.2% fidelity in 26.5 nanoseconds, demonstrating the qubit's stability and functionality. Another surprising detail is that the achieved lifetimes even surpassed the scale of cosmic ray impacts. And this suggests a resilience that is unprecedented. If confirmed in 2-qubit operations, these results could redefine the entire architecture of quantum computing. Instead of thousands of qubits, maybe just hundreds of these quantum cats, which are robust, would be enough to open doors to the future, where cryptography, materials science, and even simulations of the entire universe become possible in our reality. Schrodinger's enigma has just gained a concrete application. And what if Alice's and Bob's quantum cats really turn out to be as resilient as they seem? Maybe we're witnessing the first great leap of humanity towards the era of practical quantum computing. So, did you like this episode? If so, remember that all the sources for everything you've seen are here in the description. Thank you for staying with me. Please click one of the 2 options that will appear shortly. Today it's showing up depending on how much I'm talking at the end because I talk a lot. You know that, right? Click on one of them and I'll see you in the next one. Once again, thank you for sticking with me until now. Thanks. Bye. See you next time. Share it if you can, subscribe, and also leave that like you always do. Right? No? Thanks. Thank you. Bye. I was going to blow a kiss, but that wouldn't look good, right? Watching this is too manly. Hugs. Bye.